Unit 1, Section 4.3, Worked Examples. Convert the numeral to a numeral in base 10, and the numeral is 72,574 in base 8. We want to write it in expanded notation to do the conversion, but we need the positional values in base 8 in order to do that. And so I've got 5 positions here, so I need 5 positional values, and I start with 8 to the 4th, which is 4096. 8 cubed is 512. 8 squared is 64, and then 8, and then 1. And then I go ahead and write it in expanded form, so I have 7 times 4096, plus 2 times 512, plus 5 times 64, plus 7 times 8, plus 4 times 1. And if I multiply and add those together, I get 3076. So this numeral converted to base 10 is 30,076. Now let's convert from base 10 to a different numeration system. We're going to convert 1937 to a numeral in base 7. We need the positional values in base 7, and I've started with 7 to the 4th, which is 2401, 7 cubed, which is 343, 7 squared is 49, and then 7 and 1. And I'm going to take the number I'm trying to convert and divide it by the highest positional value in the new base system that's less than that number, and it's going to be 343. And I want to show you how I got the remainder on this. So I've got my little calculator here. So I'm going to take the 1937 and I'm going to divide by 433. So let me pull this up here. 1937 and divide by 343, and I get 5.6, etc. So I need the whole number portion, so it goes in 5 whole times. So I'm going to keep that 5. I need to find the remainder, so go ahead and subtract the whole number portion from the answer that you just got, and then multiply that times the number you were dividing by, and this will give you the remainder. So the remainder is 222. And I've written that here on the paper. So 1937 divided by 343 gives me 5, remainder 222. Then take the 222 and divide by 49, and you'll get 4 with the remainder of 26. And then drop the 26 down to the next positional value, which is 7. Divide 26 by 7, and you get 3, remainder 5. So the numbers that you need are the 5, and the 4, and the 3, and the 5. So in base 7, this number is represented as 5, 4, 3, 5 in base 7. Now let's go to a base greater than 10, because remember when we did this, we had to have other symbols to represent numbers above 9. So first of all, let's do a convert from base 12 to base 10, and you're going to do expanded form again. I've got 3 positions here, so I need 12 squared, which is 144, 12, and 1. And I'm going to write this number, 507 in base 12, in expanded form. So it equals 5 times 144, plus 0 times 12, plus 7 times 1. And if I multiply and add those, I get the number 727. So the number 507 in base 12 is equal to 727 in base 10. All right, now let's convert from base 10 to base 12. So again, the positional values that we had from the previous problem, I'm going to go one more and go up to 12 to the 4th to show you that it's larger than the number we're trying to convert. It's 20,736. And then I've got 17, 28, 144, 12, and 2. And remember, in base 12, we need to represent the numbers 10 and 11 with additional symbols, and we're going to use the letters A and B if we need those. So let's take 4708 and divide by 1728, which is the largest number, positional value less than the number, and I get 2, remainder 1252. Then I drop the 1252 down to the next positional value and divide it by 144. Should be 144. 144. Oops, sorry. 144. And I get 8, remainder 100, and then take 100 and divide by 12. And I get 8, remainder 4. So the number is, and again, remember what I need the integer parts from the division, 2884. 2884. And again, now I'm in base 12. All right, I'm going to do one other example because I want to show you what happens when you do have to use those letters to represent the numbers greater than 9. So we're going to convert from base 10, 4840 to base 16. Positional values in base 16 are shown here. And remember, again, we're going to represent the numbers 10, 11, 12, 13, and 14 with the letters A, B, C, D, and E, and F if we need them. So we're going to take 4840 and divide by 4096, the largest positional value, lessen it, and we get 1 with a remainder of 744. We're going to take 744 and divide by 256. I'm sorry, I didn't put in the right divisions here. I'm just going to cross these out. These were carried over from the last problem. And you do get 2 remainder, 232, and then take 232 and divide by 16, and you get 14 remainder 8. So here's what I need here. I need the 1 and the 2. Now notice the 14. I can't write 14 in one position. So what am I going to use to write 14? I'm going to use an E. And so I've got 1, 2, whoops, E, 8, and now I'm in base 16.